let's go ahead and take a look at a couple of questions. We want to know which five-number summary down here is represented by a graph. Well, start taking note of where some of these are. Here you have your minimum, about at this height. Here you have your maximum, about here. So, as you look here, you're going up by 2.5 units. So from 0 to 2.5, 2.5 to 5, 5 to 7.5, 7.5 to 10. So it looks like we're just a little bit under 17.5, so we know we have a maximum of 17. So that either has to be this one here, oops, sorry about that, or this one down here. Either one of these it has to be. Looking at your correct minimum, our minimum is between 0 and 2.5, so our minimum has to be near 1. And in this case, when you look at your minimums, it's either this one here or it's this one here. But this one wasn't the one with the correct maximum, so therefore it has to be B. Now also, if you take a look at this, that where your quartiles are, that can help you also choose the correct one. So here's your lower quartile, here's your upper quartile, and so on. Taking a look at this one here, we want to know, is this skewed to the right, skewed to the left, symmetrical, or what? Now here your number scale is going up. You may find it easier to have your number scale go from left to right, like it typically does. When you see it going from left to right, you see that your tail's longer on the left side, so therefore you know you're going to be skewed to the left. Taking a look here at our shoulder width of men and women, here I'm going to put in about the middle of all of our data. Here I'll put in the middle of about all of our data. And you'll realize when you're looking at where these numbers show up that the one over here on the right has a center that's greater than the one over here on the left. So therefore, our answer is the center for the distribution of A, the one on the left, is less than the center of the distribution B, which is the one on the right. IQR, which is your interquartile range. That's how far apart the smallest and largest quartiles are. So to find that, you take your upper quartile, quartile 3, and subtract your lower quartile, quartile 1. It's actually the length of your box on a box plot. Now, when you're dealing with outliers, outliers are technically defined as 1.5 times your interquartile range above or below your quartiles. So a lower quartile, you go 1.5 times your interquartile range, subtract that from your lower quartile. Any number that's smaller or below that is considered an outlier. When you are looking at an upper quartile, you go 1.5 times your interquartile range and add it to your upper quartile. Any number that's above that or beyond that is considered an outlier on the upper end. We also want to take a look at measure of spread. The measure of spread, we use typically one of two things. Either your variance, which is listed here, or your standard deviation. And your standard deviation is the same as your variance, except instead of having s squared, we go ahead and solve it for s by taking the square root of both sides, and we get your standard deviation. So just remember to go from your variance to your standard deviation, you take your square root. Or if you're given your standard deviation, to go back to your variance, you take your standard deviation and you square it. Now these are kind of scary looking formulas. Don't be concerned. We're not going to do these by hand all the time. But let's walk you through what that formula really means. So let's take a look over here. What we want to do is first of all find your mean. And once again, to find your mean, you'd want to take your data values, which we have right here, add them together, and since we have 14 pieces of data, divide them by 14. That's your mean. This formula says you want to take your data value and subtract your mean. So your data value minus your mean, and that's where this number right here comes from. Your data value minus your mean, and that's where this number comes from. And we do that for all of them. Now, your formula says you got to square that difference. So you got to take this number and square it. So you take a negative 4.4 times a negative 4.4, and you get something close to 19. A negative 3.4 times a negative 3.4, and we get close to 11.3. Now we got to add all these data values together. When we do that, we get an 85.2. Now, this funny looking E tells you to add all those together, which we did. Now it says you got to divide or multiply by n minus 1. N is once again your data value, subtract 1. So you had 14 data values, subtract 1. In other words, you need to take your sum. Instead of dividing by 14, you divide by one smaller than that and divide by 13. Then it says you need to go ahead and take the square root. So when you take your 85.2 and divide it by 13, you get 6.55. The units would really be inches squared. That's your variance. Now, your standard deviation is really just the square root of that number. So you take the square root of your 6.55 and you get about 2.56, and your units would be inches. Now, the nice thing about your standard deviation always has the same units as your mean. Also, standard deviation is always greater than or equal to 0. It's never negative. And it basically lets you know if your data is spread out a lot or a little. The bigger your standard deviation, the more spread out your data is. The smaller your standard deviation, the more compact your data is. Now, it's a lot to go ahead and do all that by hand. We don't go ahead and do that by hand. We're going to use your calculator. Now, keep in mind, since your variance formula and your standard deviation formula, go ahead and use your mean. And remember, your mean is not resistant to outliers. In other words, if you have an outlier, it pulls your mean in that direction. Your standard deviation is also going to be affected by outliers. If you have an outlier, it's going to make your standard deviation a lot bigger. Let's go ahead and use our calculator to go ahead and try to find your 5-number summary, your mean, and your standard deviation. Let's use these data values right here. So let's go ahead and pull up our calculator. We're going to go ahead and type this in. We're going to hit Stat and hit Enter and Edit. If you do have data values in here, just arrow up one, hit Clear, and then hit Enter. Do not hit the delete button. You will lose your whole column. If you by accident do that, let me know and I will help you get it back. But now let's enter our data. A 3.2, enter. The next one, a 3.2 or 4. Sorry about that. And then hit enter. And then a 4.5 and so on. And keep doing that for all your data values. Okay, I've entered all my data. So now, to be able to find the number summary that we need, let's go ahead and hit Stat, arrow once to the right, and hit Enter twice. Our one variable stats allows us to be able to find a lot of the information we've been dealing with. And then we have these numbers given to us. Notice you have a down arrow here, so that means there's more data, more information represented below. Let's talk about this on our screen here. You have the first number with an X bar, that's your mean. You also have your standard deviation. Your standard deviation on your calculator is the S with the X after it. Do not use this one here. Remember, your standard deviation is always this number here, the SX. Now, the number of data you have is what n is. When you arrow down all the way, then it gave you your minimum, your first quartile, your median, your third quartile, and your maximum. So that's how we want to go ahead and find our standard deviation with our calculator, not by hand. So let's go ahead and answer these. We have an outlier. So what's not affected by your outlier? It's your inner quartile range. Remember, your range is max minus min, so it's affected by an outlier. These two here use your mean in the formulas, so they're going to be affected. Down here, which of these statements is true? Well, the true statement is that your standard deviation is affected by your outliers. Remember, your standard deviation always has the measure of units of whatever your data is. Remember, your standard deviation is always positive. Now, this is skewed data. Whenever you're dealing with skewed data, you always want to use your 5-number summary, or at a minimum, your median and interquartile range to describe it. Your mean and standard deviation works great to describe a symmetrical shaped data set. And that's what we're talking about here. How do you know when to go ahead and use your mean and standard deviation versus your 5-number summary? If it's symmetrical, use your mean and standard deviation. If you have outliers or skewed data, a 5-number summary is always best. So here we are wondering, when a town is wondering about their income tax, which you typically have only a few rich people, but you have a lot of people of average and below average income. So it's going to be skewed to the right. When you're looking for tax-based information, you're going to want to use your mean for the town to get an accurate estimate of your money coming from your taxes. However, here it says a typical family. A typical family, you're going to then want to use your median. When you're dealing with statistical problems, you want to first of all state what it is you're trying to do. What is the question you're trying to answer? Then you want to formulate, say, okay, what is it I need to do to accomplish this? And then you want to collect that data. You then want to go ahead and take a look at your graphs and numerical summaries that occur from that. So that's what we mean by solve. And then you want to go ahead and give a conclusion. What, looking at your data and your numerical summaries, what can you say about it?